All right, students, so here are the trig identities that we wrote down before, and we're going to just add a couple more for the rest of your notes. So you should have these written down. We have sine and cosine, and then we looked at the Pythagorean theorem. So we know that our x is cosine, so we could say cosine squared, or sine squared first is our y, and that equals 1 squared. So sine squared plus cosine squared equals 1. We could write that in the other way too. So a reminder to us about what we do to one side, we have to do to the other. So this is one of our additional identities that we that are not like the top ones. The top ones, even these ones right here, those ones should be more intuitive to us, but we're going to add a couple that are less intuitive. But what we do to one side, we have to do the other. So I'm going to keep this the same. So sine square root of x plus cosine square root of x equals 1. And then I'm going to divide both sides by cosine square root of x. So on the left side, if I divide both sides by cosine squared, I can split that up. Sine squared of x over cosine squared of x plus cosine squared of x over cosine squared of x equals 1 over cosine squared of x. Now, sine over cosine, we know if we scroll back up, sine over cosine is equal to tangent. So sine squared over cosine squared would be tangent squared. So tangent squared of x. Cosine divided by cosine, or cosine squared divided by cosine squared, would be 1. And then 1 over cosine, remember 1 over cosine is secant. So 1 over cosine squared would be secant squared of x. So this one is another identity. And we might see these written sometimes in the other way, or written just in a little different form. So you can write this, you don't have to. You might see the top one written as cosine squared of x plus sine squared of x equals 1, because we can switch those under the properties of addition. The one down here, you might also see as 1 plus tangent squared of x equals secant squared of x. Another way that we might see this then is we could subtract 1 on both sides. So we could say tangent squared of x equals secant squared of x minus 1. And these are all equivalent to one another. So you might see all of these throughout, but remember that they're all equal. All right, so this was one of them when we divided by cosine squared. So I bet you know what we will do next. If we could divide by cosine squared, we can probably also divide by sine squared. So we're going to start with the original, and we'll divide. So sine squared of x plus cosine squared of x equals 1. And I'm going to divide everything by sine squared. I'm going to just skip this first step and just show dividing everything by sine squared of x. So I'm not changing it, I'm just I'm making an equivalent statement, right? Because what I do to one side, I have to do the other. And then it's the same thing, it's just applying it in a little different way. So sine squared over sine squared, we get 1. Cosine squared over sine squared, if we scroll back up, remember cosine over sine is equal to cotangent. So then cosine squared over sine squared would be cotangent squared of x. And then 1 over sine is cosecant, like we have at the top there. So we get cosecant squared of x. And this we could also write in a number of different ways too. We could have cotangent squared of x plus 1 equals cosecant squared of x. We could subtract the 1 on both sides and get cotangent by itself. So here are other options for this. You may write this, you may not write this, up to you. So cotangent squared of x plus 1. We just switch the order there. Cosecant squared of x. I could subtract the 1, so I'd get cotangent squared of x equals cosecant squared of x minus 1. So all of those are equivalent to one another. So we have all of these different properties, the ones that we wrote at the top, and then these ones at the bottom. And we use them to simplify or even to do proofs. And here are 2 examples that we have. So if I were to simplify these different examples, I'll do one at a time. Then what I'm going to start doing is write things in terms of sine and cosine. So on the left here, let's just write things in terms of sine and cosine. So I have sine of x. I'm going to simplify. Plus cosine of x times, and cotangent is cosine over sine. So the right side, the left side, we have sine of x plus cosine squared of x over sine of x. All right. Now, adding fractions, we're used to this with whole numbers, but when we add fractions, we want to have common denominators usually. So if I want common denominators, this is really over 1. I can multiply top and bottom of the left side by sine of x. And then I will have sine of x for both denominators. So then the left side becomes sine of x times sine of x, which is sine squared of x over sine of x, plus cosine squared of x over sine of x. And just like if we had an example like 4 plus 1/3, 4 is really over 1. We can multiply by 3. You can or you don't have to write this. We get 12/3 plus 1/3. And then we can really just do 12 plus 1 over 3. So our next step will be that part. We can put our denominators, make them the same. So it's because they already are the same. So we'll make it just as one fraction, just like how we did in the middle here. And then we can simplify that. So sine squared of x plus cosine squared of x, that was our first identity from before, right? That's just using the Pythagorean theorem in our unit circle. So the top here is equal to 1 over sine of x, and 1 over sine is equal to cosecant of x. So we were able to simplify that whole thing down to cosecant of x. All right, the next one here, cotangent squared of x plus sine squared of x plus cosine squared of x. Now, with the addition part, I want to see first, going back to the page before. So I could change everything in terms of sine and cosine, but I noticed that with addition, I want to kind of see if there are any of these identities right away. And I noticed that it has sine squared of x plus cosine squared of x. So this part right here, sine squared of x plus cosine squared of x, that whole thing just equals 1. So I can say cotangent squared of x plus 1. And that was that whole sine squared plus cosine squared. Then cotangent squared of x plus 1, if I look back again, you already have it right above. So cotangent squared plus 1 is equal to cosecant squared of x. So here, this part right here is equal to cosecant squared of x. So that is as simplified as I can make that. Now in class, we'll practice proving. So I'll say, how do you get from this to this? And it's a little easier to know when you're done with a type of question. But for now, all of these identities I would study over the weekend, making sure, or before your next class, making sure that you remember, especially the ones that are in boxes here, remembering these two, and then always remembering these at the top. Even just pick one of the sides to remember, because they're symmetrical to themselves, right? So that is the rest of your notes for the day, and I will see you at your next class. See you.